Hey guys, I'm back. I figured while I'm at it here, I pulled up these space weather charts for the last run. You can run it back as far as 300 frames. So I got them all up here. This is the magnetopause. For anybody that's new, this dotted line circling the planet, that's where the GOES spacecraft, excuse me, orbit around. Like I showed the GOES 16 water vapor image loop. I'm pretty sure that's up there somewhere too. On this, probably on this geosynchronous orbit, because this is an easy orbit for them to maintain. It's at about 22,236 miles, somewhere around there, 360 miles. It's around 22,000 for sure. Okay, now here we go. We got all this backside pressure coming in, which should not be. Basically, it's forcing our magnetosphere to develop another bow shock behind the Earth to protect us from all this solar wind energy coming from the binary twin nemesis. Has to be. So our sun's out here. This is the light side of the planet. There's the dark side. This is a representation of how big Earth is. These lines here indicate Earth radii, which is like 3,959 miles, the radius of the Earth. So you can see the magnetopause normally sits about 10 Earth radii out here, unless it encounters some solar wind pressure. And you'll have these are magnetic field lines. The black ones are the polar cap ones. The red ones are closed. Usually we only get closed ones where there's solar wind pressure, because it closes out, helps it to strengthen the magnetopause. But as you can see, we get almost constant closed field lines behind the planet now in order to combat this extra pressure. I have these all pretty well synced time-wise, especially these three. These two might lag a little behind because they're differently calibrated. But here you can see what I'm talking about, this extra bow shock behind the Earth. Here it is there. Those are the closed field lines trying to ward off all this extra energy. And in the meantime, Earth's absorbing a lot more energy. As you can see it bleeding in. These are the lowest energy electrons. In other words, they are the slowest moving electrons, if you will. That's how I understand it. And this is at the lowest energy level reading at 10. I'm not sure the KE, what it stands for, volts. Kelvin volts, I think it is, maybe. And then this is the highest energy electrons. These are the ones that move around real fast. And they're measuring them. This is the highest measurement available on the simulations, and this is at 4,000 keV or 4 MeV. So maybe the keV is not Kelvin. Maybe that stands for million, that stands for thousand, the K. But anyway, that's a moot point. I didn't really try to figure that one out. I didn't think it was that important. So anyway, there we go. We've got all this energy bleeding in, and the Earth tries to repel it, and it tries to have to unload it sometimes, because what happens is it builds up. Then all of a sudden, the Earth's going to make a big discharge. And this is all plasma. This is like pure electron energy, high energy stuff. And the planet's trying to shed it because we're getting inundated. And that's why you have the all the extra seismic activity that's been going on in the volcanoes. I mean, there's like probably close to 50 volcanoes that are active now. Excuse me, which the normal would be between 10 and 20. And that number's been steadily climbing the last several years. but now it's at an all-time high. I think it's close to 50 last time I noticed. Now this is the earthquakes just in the last 48-hour period that the USGS is reporting at 4.5 or greater worldwide, and 2.5 or greater in the continental United States, or Hawaii too. You can see they still got some earthquakes going on in Hawaii as well. Nothing real big showing up right now, but we have had some deep earthquakes, as you can see here. See these real deep ones? And it's been pretty common lately, last few years, for this area of the planet over by Fiji and Vanuatu Islands and so forth. And these are really deep. I mean, 579, that's pretty far down into the asthenosphere. 479, that would be considered a deep earthquake. If you take it back 7 days, we'll just take the rings down. You can see we get quite several deep earthquakes out here, even up to 625 mile or kilometers deep. There's a deep one up here. Not sure where, I think it was 490 something or whatever. But anyway, that's not normal, guys. So that means the planet's getting supercharged, and the magma is getting charged up. So as you can see, why we're getting a whole bunch of energy from the backside, and it's been going on for the last couple of years, but it seems to be getting worse. Now these blue lines are interplanetary magnetic field lines. Normally we only have should have 9. We have one sun and about 9 planets in our solar system. And the interplanetary magnetic field lines represent a magnetic connection from the sun to each of the planets. As you can see, there's plenty more than 9 here. So that would lead me to also conclude that our binary twin sun, of course, it's putting out magnetic field lines. It's connecting to all of our 9 planets, plus it's supposed to have 7 planets. So that makes 9 plus 7 is 16 planets altogether, times 2 suns. That'd be like 32 magnetic field lines. And as you can see, we've got quite a few magnetic field lines. And look at all these ones that are building up in front of the planet. That should not be. This is the proof, the solar wind speed here. This is the proof that there's some other sun. There might even be more than one sun. There's definitely something big back here producing a lot of energy, unless it's, I know there's one out here somewhere between the ACE satellite. That's the one that measures this stuff here. I'm going to show you a live look. It's 1.5 million kilometers stationed out in front of the Earth, between the Earth and the Sun, at the L1 Lagrange point. This is it here. Okay, it stays there 24/7. It's in like a constant fixed orbit position. And these are the other Lagrange points. This is where the stereo behind spacecraft is located, which they say has been inoperable for the last several years. So we're not getting any shots from that. This is where stereo A is. They don't show you anything from back here. According to them, they don't have anything back there. And I'm not sure what's out. I think maybe one of the LASCO ones is out here in L2. But anyway, I don't have a lot of time. Here's the ACE right here. Here's the ACE data from the last 24 hours. So here's 9:14, and there's always this like gap. Usually it started around 2300 and went to about 600. So now it's changing. Now it's up to 0100 on the 15th to about 0700. That's a telling thing there. There's something in here that's blocking this data coming from the sun to the ACE satellite, but that's not the point I wanted to make. See the solar wind speed? Remember, ACE was located in between the sun and the earth, so it just measures everything out here coming from the sun, right? So the solar wind speed up until when we lost data was climbing. It went up to close to 700 kilometers per second. And once we started regaining the data, it was down around 600 kilometers per second. And then there was a steady decline. But if you look at this here, okay, I'm going to do it like this. So we started picking up data around 0600 on the ACE. And so here we go, solar wind 555. So that's okay. That corresponds. Then it jumps to 630, then 600, 500. That's still pretty fairly constant, 645. But it shouldn't be going up to 660, and then 720. 720 at 07 1300 hours UTC. I don't think so. Here's 7 up here. There's the 7 line. So we're getting some solar wind. It's coming from somewhere other than the sun, our sun. And I think it even goes up to 8 at some point. 782, 799, 657. Okay, so you can see my point. Get this back on sync. Roughly, anyway. All right. So you can see my point. Solar wind coming from the sun was on a steady decline, and it went up. Okay, here's the latest MLSO run. Mauna Loa Solar Observatory in Hawaii. You can see the magnetic signatures. That's what this is, like a magnetic type of photograph, gamma coronagraph photograph, as far as I can understand. Anyway, we've still got these celestial objects. I would concur that they're celestial objects, and they're showing some type of a magnetic field. Which, you know, all the planets, most of the planets have a magnetic field. Earth having a very strong one. Mars, it pretty much got its ripped away on one of the other passings of the Nemesis Nibiru system, along with its atmosphere. So that's why Mars is in bad shape. It probably had some habitation at one point. But anyway, here's some more circles, planets or moons in the Nemesis system. I would have to say, yeah, because they correspond to a lot of the different photographs I've been seeing, especially from the Alaska FAA webcams and some of the others. I got the videos saved in my prophecy blog on a lot of the entries. Getting back, okay, well, running out of time here. Guess I pretty much covered everything. Oh, yeah. I put up another good one on Florence today about the atmospheric river they got going. But here's what I want to show you. Go on my profile page, click on the videos, and you can access a lot of this information from space weather videos I've made. Because I can't possibly cover everything in 15 minutes on one video. None of these videos are longer than 15 minutes, and I'd say they're all well worth a listen, no matter which one you pick. started putting them out again back on 119 when my channel came back up. God bless.